So hi guys, today we're gonna talk about direct proof, and this all will be our first example. So the question says that if a and b are rational number, I want to prove that a minus b is also a rational number. So you could always start these questions by defining what is a rational number, which will be quite helpful. Which I'm gonna do here, right? I'm gonna write let q, which is rational number, be c over d, where c, d are integers and d is not equal to 0, right? Any the definition of a rational number is that a rational number can always be written in the form of an integer divided by another integer. I say that d cannot be 0 because if 0 is on the bottom, then it will be undefined, right? That will be wrong. So let's actually start our formal proof. So kind of write proof, right? So at the first start of the proof, you always want to write WTS, which stands for want to show. So what do you want to show in your proof? What do you want to show that is right? Well, in our case, we want to show that a and b are both an element of rational number, and a minus b is also rational number. That's what we want to show, right? So this is kind of an interesting proof. So what we do is that we say this: let C, D, E, F be 4 integers and D, F are not equal to 0, right? So you can see the question that we want to prove A minus B, right? And we already know that A and B are rational numbers, so we can write it in the form of C over D minus E over F according to the definition, right? If A is a rational number, it can be written in the form of an integer over another integer, which I do in this case as C over D, where I already assume that C, D are both integer and D cannot be 0. D and both F cannot be 0, right? So it makes sense. So what will be our next step? Well, our next step will be doing the algebra, right? So how you already probably learned this in a grade 8 high school or something like that. How would you minus this, right? You can write this in the form of C times F. You want to times the left side by the bottom, so C times F and D times F minus. So what is the right side missing? Well, it's missing D, right? So D times E and D times F. So now we have the same thing on the bottom, so we can actually minus them. So what would this be, right? So what would this be? This can be simplified to C times F minus D times E over D times F, which, if you look at this whole structure right here, does it look familiar? Yes, it's an integer over another integer, right? Which is exactly the definition of rational number that we mentioned before. Well, you might ask, why is this an integer over an integer? Well, the top C, F, D, E, we already assume in this section that they're all integers, so they cannot be so no matter what these number no matter what you assume they're all integer. If you times them, minus them, then do all the math, they will come out as an integer on the top, and the bottom is an integer times another integer, which will be an integer, right? So we have a form of a integer over another integer, which is satisfy exactly the definition of a rational number, which is an integer over another integer. So therefore, so you will write therefore if A, B are element of a rational number, then A minus B is also a part of Q, which is rational number. So therefore I just prove the following proof.